Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem Champagne Tower. You can see its index is 799 and it is the medium problem of the LeetCode. Okay, so before moving on, let us talk about the prerequisites required to solve this problem efficiently. So basically we are going to use the concept of dynamic programming, like how we are going to use the already pre-computed values to find out the values at the current state. Okay, so also I would strictly recommend you guys to read this problem at least once, because I'm not going to read all those long statements. Rather than I'm going to explain through the diagrammatically how this problem is going to state, and how we're going to find out the solutions efficiently, right? Okay, so let's begin. So you can see we are going to have the glasses placed over there, and when we pour some X glass of water, or you can say we are going to pour some champagne. So but now let's say we are going to pour some X glass of water. So when X is 1, so it means that we are going to fill this complete like that. Okay, so when X is 2, right now when X is 2, you can see when we try to fill water over to this glass that is present at the layer 1, some water will overflow, and that overflow water will be going down over here. Okay, so the main idea is how to estimate how much amount of water will overflow. You can see the glasses are placed like equivalently, when you pour some extra one glass of water, exactly 1 by 2 glass of water will be going over here, and 1 by 2 glass of water will be going over here, right? That is at the step x equal to 2, this will be completely filled, and this will be half filled, and this will be again half filled. Now when x is 3, you can see again 1 by 2 amount of water will go over here, so this will be completely filled, and this will be completely filled, right? So this is the sequence of steps we are going to use. Okay, now when again x is 4, now this is quite tricky. So when you pour this exactly one extra glass of water right over here, so you can see 1 by 2 amount of water will come over here, and 1 by 2 amount of water will come over here, and that would be an extra amount of water, so that will also overflow. So 1 by 4 amount of water will go over this position, and 1 by 4 amount of water will go over this position, and again 1 by 4 amount of water will go over this position, and 1 by 4 amount of water will go over this position. So this is the exact trick to understand how much water will flow to the adjacent glasses to the layer below the current layer. Okay, so how to find that? In this problem we need to find how much the glass is filled with water, how much the glass is filled with water, how much the glass is filled with water when x amount of water is poured to the very top glass. How much water is filled with wait a minute, how much the glass is filled with water when x amount of water is poured. Note that this glass is actually, we are talking about any random glass that is present in let's say that is present in ith row and jth column, sorry, jth glass. That is, let's say we are going to pour x equal to some, let's say 150 amounts of water at the top of this glass, and we need to find how much the glass is filled at the position, let's say fourth row and third glass. So it means that this is the very first row, this is the second row, third row, fourth row, and the third glass is this glass. So we need to find how much water is filled in this glass, how much the glass is filled with water in this glass, right? Okay, so how we need to find? So the basic idea is to perform uh, you can see breadth first search, you can also say breadth first search with little dp. Dp is nothing but we need to store the values. Okay, so when you are at this first glass of water, let's say x amount of water is poured. Okay, so we will subtract x minus 1 because this is completely filled. So this x minus 1 water will be going to this glass, and again this glass will also contain x minus 1 upon 2. Okay, so again this remaining glass will go x minus 1 upon 2 which is 4, and this also x minus 1 upon 4, and this also x minus 1 upon 4, and this we are going to have x minus 1 upon 2, sorry, x minus 1 upon 4. And again in the sequence of steps the water will go like that, where x is the amount that is being filled at the you can see at the top of this glass. Now there is one mistake that I have done. And what is that mistake? Like if you haven't noticed, uh, when x amount of water is poured to this position, then you can see the remaining water is x minus 1 because this is filled, and then x minus 1 by 2 amount will go over here, x minus 1 by 2 amount will go over here. Now when this glass is filled, when this is filled, then only this water will overflow. Okay, so what you are going to do is you will first find out this value x minus 1 upon 2. Let's say the value is coming out to be 50, let's say for an instance. So when it is coming out to be 50, then you will subtract 1 because this is filled, so it becomes 49. So 49 by 2 will go over here, and 49 by 2 will go over here, right? So again here also 49 by 2, so there x minus 1 by 4 is quite wrong, so you're not going to write this one. Okay, so what you're going to do is you are going to find out the sequence of the steps first, then they will subtract 1 if the glass is filled, and then you'll pour the extra amount of water to the glasses that is present in the below layer. Okay, so let us understand by taking an example. Let's say x is 5. Okay, so what you are going to do is, so 5 amount of water is going to be at this position, so one glass of water will take to completely fill this one. So we have extra 4 amount, so 2 amount will go over this position, 2 amount, and 2 amount will go over to this position. So 1 amount will take to completely fill this one, and 1 amount will take to completely fill this one. So extra left over is 1, and left over here is 1. Okay, so you can see, so 1 by 2 will go over here, and again 1 by 2 will go over here. So extra is 1, so 1 by 2 will go over here, and 1 by 2 will go over here, right? So if you are asked the what is the amount of water, how much the glass is filled, so you can see 1 by 2 plus 1 by 2 is 1, so it is completely filled, completely. Well, you need to actually return the ratio, right? I will tell you how we are going to do that. And here it is half filled, and here it is also half filled, right? So let us understand the code, how we are going to do that. Okay, so your time complexity would be O of R into C, and space will be O of R into C because we are considering every glass, and we have odd amount of layers in maximum, and we are going to use the matrix to store the data, how much amount of water is filled. So I have a vectored matrix of double type. Okay, and size will be query row plus 1 and query row plus 1, that is n cross n type of matrix where n is query row. So I will start with a queue containing 2 indexes, like we are filling out the values layer by layer. Okay, so the very first layer will contain 0 comma 0, that is the, you can see actually it is saying that we are having in the 0th row, and glass number is 0th glass number. Note that everything is based on 0 based indexing, right? So dp of 00 is exactly equal to pod, and yes, we are going to do layer by layer, so we are going to iterate up to this amount of time. You can see I is 0 less than query row. So take the query size, sorry, queue size, and work on every glass. right? So extract the class number, like row number of this class, column number of this class, pop it out. Now uh, you can see this data is this dp of xy, which is actually, you can see the amount of water that is present over here. Now if it is less than 1.0, you can easily see the glass is not filled, or let's say it is 1.0, so glass is completely filled, so none of the water is going to be overflowed. So in that case we are going to use the continue, we are not going to move further. Otherwise extract, like subtract data minus equal to 1.0, because it will take exactly one glass of water to fill it. Okay, so now we have some remaining values. Okay, the data will contain the remaining values of extra water that is being overflowed. So it will be overflowed in the equal direction to the both of the glasses that are present to the layer below it. So I will check it out if dp of x plus 1, with that is the glass present in the next layer, and the y, it means that the same glass corresponding to that. So if you're not visualizing it, so let me just explain. So you can see it is 0 comma 0, and it is 0 comma sorry, it will be 1 comma 0, and it will be 1 comma 1, and it will be 2 comma 0, it will be 2 comma 1, it will be 2 comma 2, like that. So I will check it out, dp of x plus 1 y exactly equal to minus 1.0. Okay, so yeah, so minus 1.0 denotes that the glass is empty, right? So yeah, if dp of x plus 1 y is minus 1.0, it says that it is empty. So we are going to fill this value with data divided by 2.0, because the glasses that are present directly below the current glass and the layer below it will be filled with equivalent, like equal amount of waters that are being overflowed. So data is contains the water being overflowed, data divided by 2.0 will be the water going to the left glass to the layer below it, and again this one is also going to do the same thing, data divided by 2.0. Now yes, if this value is still not processed, that is the glass is not having the water, so you are going to push it into the queue, the glass number x plus 1 comma y, and also initialize with data divided by 2.0. And yes, if it is already being having some water, you need to increment the water present in that glass, that is dp of x plus 1y plus equal to data divided by 2.0. Okay, so basically it is doing nothing. Suppose you are at this glass and you are going to pour the water over to this one. Now this entry is not in the queue and it is unfilled, so you will first fill it. Okay, so when you come to this glass, you can see this is already filled, that is this is already filled, so you will add some more water to it. So this is what we are going to do, and again this is for the x plus 1 y plus 1. Okay, now when this all goes well for all the layers, you can see I less than query row, if dp of query row and query glass is greater than 1.0, right? So it is greater than 1.0, it means that the glass is completely filled. So you need to return how much the water is filled, it is actually the ratio. So you will return, you will assign this value as 1.0. Otherwise also it is like unfilled, you can see, so you need to return 0.0 according to the problem statement. Otherwise you will return the ratio. So what you're going to do is like you will divide by 1.0. okay, so it is nothing but it remains the same. So if you either remove it, it doesn't matter. And finally you need to return this value, dp of query row and dp of query class, right? So this will give you all test cases passed. So if you guys have still any doubts, do reach out to us to the comment section of the video, and thank you for watching this video.